Hello. Well, stick around because for the next 3 minutes I'll be showing you how networks fit together, what network engineers actually do, and I'll be letting you in on a trade secret, how we monitor the network and how we know exactly what's going on. But first I'd like to show you around the lab I have created here. It's based on the same protocols and principles used by large corporations. We have a mantra that says, if we cannot reproduce a problem, we cannot fix it. So the lab is the ideal space to isolate the problem and test a fix before releasing it to the live network. That way we know it's going to work. For the purposes of this video, I'm going to focus on 3 types of network elements here. There are switches. These connect local machines together, say from your machine to the person sitting next to you. Then there are routers. These connect groups of machines, say from your department to another department in your building. We call these groups subnets. Now routers can also be used to create wider networks, or WANs, that connect, say, your department's subnet to another department's subnet in another country. We can also connect through a filtering device, often called a firewall, to the internet. The firewall can accept or block traffic based on direction and type of traffic, and we define rules to govern security between the external and the internal networks. For instance, we might want to block certain incoming traffic to protect our own network. But there are also filters on the other network elements too. For example, the switches can block based on machine address, and the routers can block based on source, destination and direction of traffic. We call these router rules access control lists. And we know that most PCs have firewall protection too. So when maintaining a system or upgrading its security, it's vital to understand how the network is designed. And it's also vital to have a solid network configuration management system so that when changes are made, they're documented. So our role as network engineers is to make sure that traffic flows where we want and to keep out unwanted traffic. Of course, there are many different problems such as denial of service attacks and virus protection, and many different types of traffic such as FTP, social media, email and so on. How can we possibly keep track of all of this and identify problems before they occur, especially if our networks are spread across the globe? Well, we have to work smarter. PRTG might not sound very sexy, but it's the name of some visualization software that's really going to help us out here. I've set up a demonstration in the lab showing how it works. The router I want us to focus on is Angel, and we'll be looking at the traffic flowing from the machine LPC host out to the Virgin Internet Media. This is where PTRG is running, which monitors Angel's traffic using a protocol called NetFlow. NetFlow is information about the traffic flowing through the router. To start with, PRTG first scans the network to discover the network elements, shown in tabular form here. Then we add a sensor to the router Angel. This is going to send its NetFlow information back to the PRTG management terminal, which will store this information in its local database. Now, supposing there is an incident on the network, and all the information we are offered is when this happened. We can look at the traffic flowing through Angel at that time, and the information is displayed as a chart. This tells us that 58% of the traffic originates from a single IP address. An IP address is a logical address given to each network element. I can look up this address to discover that it's owned by YouTube and it's located in Mountain View, California. PRTG also lets me see the machine connectivity, and indeed we can see that the connection from the YouTube address is directed to our machine LPC host. So now we've established that at that time more than 50% of the traffic on that router is YouTube traffic directed to LPC host. Of course, that simply tells us what's going on. We have another process to decide what to do about it. But knowing this information is 90% of the solution. Well, I think PRGT is great technology. It's a subject in its own right. Well, I hope you've enjoyed this, and I hope I've explained what it is that we do, why it's important, and how we can keep track of it all. And I guess for now, there's only one thing left to say. Beam me up, Scotty.